Okay, in this problem we have a car driving north and a truck driving east, both away from an intersection that they had previously been in. And we're trying to find out how fast the distance between the vehicles is changing with respect to time. So we're talking about how fast is this distance changing. Let's label this distance L. So what we want to find is dl by dt. We want to find the value of dl by dt. We want to find the value at the 45-minute mark, so 45 minutes after the truck starts driving. Let's work in hours for this question because everything is in kilometers per hour. So 45 minutes would be 3/4 of an hour. Let's label the distances away from the intersections as A and B. So the distance the truck has driven away from the intersection is A equals 100 times T, because it's driving at 100 kilometers per hour. T is the time in hours. Similarly, B would be equal to 80t, but the car had a head start of 30 minutes, and 30 minutes is half an hour, so the head start is 40 kilometers. So we'll add the 40 kilometers onto B. So we're trying to find out the value of dl by dt. That's a rate of change. We're given two rates of change in the problem, 80 and 100. Those are both rates, aren't they? Because they're written as kilometers per hour, so they're rates. They are dA by dt and dB by dt. So there's the relationship. We're going to have a relationship among these three rates of change. To find the relationship between the rates of change, we first of all need a relationship between the three variables, L, A, and B. That's easy. We have a right-angled triangle, so we can use the Pythagorean theorem. We know that L squared is equal to A squared plus B squared. If we now differentiate that expression with respect to time, t, that'll give us the relationship among the rates that we need. So if we differentiate with respect to t, time, that'll give us 2L times dl by dt, that's the chain rule in action, is equal to 2A times dA by dt plus 2B times dB by dt. There are three terms here, one on the left side, two on the right side. Each of them has a 2. We can therefore divide everything by 2 and in effect cancel them out. So we're trying to find the value of dl by dt. So this is the thing that we're trying to find, dl by dt. So we'll need to know the value of L, the value of A, the value of dA by dt, the value of B, and the value of dB by dt to solve this problem. So do we know all these things? Starting at the right-hand side, dB by dt, yeah, we know it. It's equal to 80. That's how fast the car is driving. B, do we know what B is? At the 45-minute mark, if we substitute 3/4 right here for t, then B will have the value (80 times 3/4), that's 60, plus 40. 60 plus 40 is 100. So the car is 100 kilometers from the intersection. dA by dt is how fast the truck is driving. That's 100. And the value of A at the 45-minute mark, well, we need 100 times 3/4. That'll be exactly 75. Okay, we don't know dl by dt, so that'll have to stay as dl by dt. We're going to need the value of L. Well, we do have this formula up here, so we can find the value of L fairly easily. So at t equals 3/4, L is going to be the square root of 75 squared plus 100 squared. And that works out nicely to exactly 125. So that goes here, 125. Solving for dl by dt, you end up getting an answer of approximately 124 kilometers per hour. So therefore, the distance between the vehicles at the 45-minute mark is increasing at the rate of change of 124 kilometers per hour.